ada reminder. So this week we proceed with EDA, Exploratory Data Analysis. Okay, I do hope that everybody has no problem to insert your data in data set, to insert to run your reliability, to proceed with the instrument validity. So I do hope there is no more problem on that. So we proceed with EDA. So EDA is a process that is necessary after nanti kita discuss apa itu purpose of EDA. So this is our LO. At the end of the session, students are able to determine the purpose of EDA, describe the principle of EDA, analyze and evaluate normality and equality of variance assumptions according to the statistical analysis. Okay. So the process of EDA is necessary before we start proceed with the actual data analysis. Okay, so after we key in our data into IBM SPSS or any other statistical software, we need to confirm. Okay, we need to confirm what type of statistical analysis that we want to use according to our research objective. Okay, and then we need to do the somehow the EDA is part of data screening lah, data screening process. We need to macam kalau early stage in data screening process tu, we identify the missing values. Okay, we identify either the respondent correctly tick the answer. Tapi the purpose of at the stage of EDA ni, we are more towards looking for the assumptions, the required assumption according to statistical analysis. Okay, if let's say we want to use parametric statistic according to our research objective, by the way, I do hope that everybody can differentiate between parametric and non-parametric. Ada isu lagi nak differentiate tu. What is parametric statistics? So that kalau kita faham semua, then kita akan ada similar understanding lah. What is parametric statistic?
Data is normally distributed.
Maksudnya the data met the assumption of normality. Okay, so maksudnya kita nak tengok sebenarnya data kita ni normal ataupun tak, ataupun kita nak check juga is there any outliers. Outliers ni maksudnya data tu falls beyond the majority. Sebab kalau dalam quantitative study ni, we are not interested in the minority. We are not interested in the minority. We are more towards analyzing data ni according to the groups standard. Kita tak nak tengok outliers, tak nak tengok extreme values. Itu yang kita cuba identify through the EDA. Okay, so the purpose of EDA first to get familiar with your data. Maksudnya we are familiar with our scaling. Okay, and then we are familiar with the way we use code in our data set. Okay, kita nak familiar dulu dengan data kita, and then to confirm data has been entered correctly. This one to make sure that if let's say we set our scale 1 to 5, then all the key information tu, marks tu according to 1 to 5 range only. It not goes beyond that limit. Okay, kita nak check hak ni. Okay, next one to state frequency distribution of a data set. So this one we want to report findings that is related to descriptive according to the variables. This part juga kita nak analysis on demographic finding. Okay, and then to state the shape of distribution of a data. We want to identify either our data ni is normally distributed or not. It doesn't matter either it is normally distributed or not. It just depending on our objective, which statistical analysis that we want to use. Okay, to describe the location of a data. Because if let's say our data is negatively skewed, then probably there are few descriptive analysis that not supposed to be reported. For example, mean. Dia ada lagi analisis lain yang kita patut report kalau let's say data kita negatively skewed. Okay, positively skewed ke. Okay, next one to describe data variability, and then to screen data. Okay, to identify outliers, and then to identify the extreme values. Outliers, extreme values sama lebih kurang, to ensure assumption of analysis tentatively satisfied. Okay. Okay, so in EDA, there are two important principles, skepticism and openness. Skepticism meaning that we open we have a curiosity. We always have the curiosity that our data might be wrong. And then kita kena ada curiosity tu dalam data. Ada probability yang we insert the wrong data and then we obtain the data from the wrong person. Ada possibility tu. And then therefore we need to be open. If there is any changes necessary in our data. Kalau let's say we have to delete, then we have to delete the case tu. So these are the two principles in EDA. Okay, data requirement. Okay, to run EDA ni, it depends on the type of scale of measurement of our data lah. So basically we have interval or ratio, and then in terms of nominal and ordinal pun possible juga untuk kita analyze. Okay, and then okay, so to start with kita tengok the frequency function. Okay, frequency function ni it is one of the analysis under EDA that we can use to check either our data falls within the correct location. Okay, so to run this function, you just click analyze, descriptive statistic, and then frequencies. Okay, then please use the data that I've shared earlier. Then you can use or familiarize yourself with this function. Okay, click analyze, descriptive statistics, and frequencies. Okay, dah buka belum data? Saya buka data yang tadi lambat sikit tu. Dan okay, analyze, descriptive statistic, and frequencies. Next one. Okay, under the frequency box, you insert, for example, PB mean. I do hope that everybody already calculate your mean score. Okay, we use mean score. For example, PB mean. You insert the PB mean under the variable column. Okay, next one, you click statistics. Click button statistic. This one, click statistics. Okay, in statistic button, you check for quartile. Okay, under percentile values ni, check for quartile. Okay, under the MCT ni, under central tendency, you tick for all, mean, median, mode, and sum. For dispersion, you tick all, standard deviation, variance, range, minimum, maximum. And then for distribution, you may check for skewness and kurtosis. Dan kita buat sekali terus. Okay, quartile, standard deviation, variance, range, minimum, maximum. Okay, skewness, kurtosis, mean, median, mode, and sum. Okay, and then click continue. Okay, then go to your output to check on the finding. Do we have similar thing? Okay, the first box, which is statistics table. Okay, so the statistic from the statistic table ni, we might be interested with the mean. Okay, most of the time we are interested with the mean value lah. The mean value is 3.8563. Okay, and then median, mode. Okay, since the location to is quite close to each other, so then based on the mean, median, mode. Okay, mean, median, mode ni pun can be used as an indicator to state or to report our normality. If the mean, median, mode ni is equal to one and another, we can assume that our data to be normally distributed. Tapi dia adalah sikit ni, tapi close lah, still close to each other. And then our standard deviation, okay, the variance, the skewness value. Okay, so the skewness value ni, based on the skewness value, we can see that the value is 0.742. Okay, kalau if let's say we use the plus minus 2 as an indicator. Okay, so this one we consider as slightly positively skewed, but still normal, slightly negative, positively skewed, but still, since it's still falls within the range, so we consider it as normal. Yang ni pun boleh to check your normality, the skewness pun boleh. Okay, next one, kurtosis. What is the cut-off point for kurtosis when you learn during your statistic class? Plus minus 7.
7, sorry.
Plus minus 7. Tapi plus minus 7 ni sebenarnya dah skewed dah ni. Okay, so for this class, why not we reduce it to plus minus 3. Okay, so for curtesis ni we use plus minus 3 as the indicator. So this is we report the value of the curtesis value is 0.035. So it still fall within the range of plus minus 3. So therefore we assume our data to be normally distributed based on curtesis. Okay, so then from based on range ni the maximum minus the minimum, therefore we will get the range lah. Okay, so but minimum maximum ni we can check either we insert the right data in our data set. So we can see that based on the minimum maximum ni, the maximum is 5 because our data, if let's say we use 5 like scale 1 to 5, so we need to know that our data set, the maximum ni cannot exceed 5, cannot be more than 5. Kalau kita nampak ada yang lebih daripada 5 tu, maksudnya something wrong with our data. Okay, you need to go to your raw data and then delete or improve that case. Okay, so kita boleh tengok kat sini, so dia still falls within the range of 1 to 5. So therefore, the data should be okay lah, this one. Okay, so then this one is the valid case. Okay, this one report according to the individual case lah. Okay, how many frequency responders score 2.88. Okay, and then so on. Until 5 ni. Ni kita boleh tengok satu-satu case. Okay, ni detail. Okay, next one. Okay, so ini pula kalau valid case ni, kalau let's say it indicate that the valid case is 60 because the sample that I have in our data set is 60. So meaning that there is no missing value. Okay, dan standard deviation dah. Okay, next one, descriptive function. Okay, so now so descriptive function ni, okay, so sebenarnya kalau you klik tadi analyze this descriptive and then descriptive pilih Okay, so you will get this function. Okay, cuba you buat apa yang you akan dapat. Okay, analyze, klik analyze, descriptive and then descriptive. Dapat tak? Dapat? Okay, and then after the descriptive box appear, you insert the PB min. Okay, and then you click the option button, click option button. Okay, for option button, you can tick for similar thing, mean, standard deviation, variance, range, minimum, maximum, curtesis and skewness. So sebenarnya descriptive function ni sama dengan frequency function tadi, lebih kurang. Okay, and then click continue. Sama juga sebenarnya. It's repetitive lah. Okay, dia report hampir benda yang hampir sama. Okay, statistik and valid case, range, okay, minimum, maximum, the mean, standard deviation, variance, skewness and curtesis. Dia tak ada kuartal tu je. The rest hampir sama. What about plots ni? Explore function. Okay, so kalau you pergi dekat explore function, you tick for normality plots ni. Ni dia akan more in depth on normality lah. Tadi kita report normality based on mean, mode and median. Next one based on skewness and curtesis. This one based on you can also report the normality based on stem and leaf, histogram, and then normality plots. Box plot pun boleh. You can also report your normality based on box plot pun possible. Okay, normality plots. Okay. Next one. Okay, this one is saya lah slide punya slow lari sikit. Saya punya slide lari sikit. Okay, this one if you use the explore function if you use explore function, then you just tick for explore, include the your variable under the dependent list, and then click plots. For plots ni, you tick for stem and leaf, histogram, and then normality plots with test. Okay. Okay, and then go to statistic box. You tick for descriptive confidence interval, outliers, and percentiles. Ini we will identify the outliers in our data set. Okay. So this is the finding from the output from the explore function. So it's quite similar. It's report the valid case, no missing value, no missing case. Okay, and then this is the total cumulative. Okay, in terms of descriptive, it will report the mean. Okay, the mean. Rata. Okay, 95 confidence interval for mean, lower bound and upper bound. Okay, 5% trim mean, median, variance, standard deviation similar. Value dia similar dalam indescriptive and infrequency function sama. The value should be similar. Minimum, maximum, interquartile range and skewness kurtosis similar thing. Okay, ini adalah explanation regarding 95% confidence interval, 95% confidence interval and mean upper bound, and then 5% trim mean. Okay. Next one. Ini next box here. Okay, this is the percentile. Okay, 25th percentile to 75th percentile. So hopefully our data falls within this one lah yang kita nak ni. Okay, and then the extreme values. Okay, the extreme values ni again the value that falls beyond the majority. Okay, so ni dia akan highlight the case. For example, case 31 ni. Okay, the score is 4.88. Ini mungkin this extreme values ni has the higher tendency to make our data not to be normal. Inilah the case that has the tendency for us to be deleted. Okay, and the next one adalah the test of normality by using statistics, which is two statistics that I'm sure you already learned during your statistic class, which is Kolmogorov-Smirnov and Shapiro-Wilk. Okay, so what is the criteria to read the Kolmogorov-Smirnov and Shapiro-Wilk table? We look at we refer to the
significant value.
Significant value. We refer to the significant value. If the significant, then we compare against alpha, either 0.05 or
0.01.
0.01. Okay, so if let's say we set it as 0.05, so we compare these two value. If the significant value of Kolmogorov-Smirnov, for example, lesser than 0.05 means that our data
normal distributed.
lagi sekali. If let's say our significant value lesser than alpha 0.05, so therefore if significant value of Kolmogorov-Smirnov lesser than alpha 0.05, therefore
Not normal.
not normal. Terbalik tu. Apa yang jawab tadi tu? Okay. If our significant value larger than or equals to alpha 0.05, therefore our data considered to be normal. Okay. So actually the test of Kolmogorov-Smirnov and Shapiro-Wilk ni is really stringent. Difficult for you to prove that your data are normal if you use these two statistics. So that's why most of researchers tend to use skewness and kurtosis ataupun any other alternative because it's very difficult, stringent, unless you have a very huge sample biasanya untuk guna Kolmogorov-Smirnov and Shapiro-Wilk ni. Okay, make sure you remember the requirement. Okay, any questions so far? Ada. Okay. Next one. You can also check for your normality by using histogram. Histogram or stem and leaf plot. So this is a way to read your data normality according to figures. Selain daripada statistik, kita boleh juga report our normality according to figure. So if we look at the histogram distribution ni, you just draw the line. You just draw the line from the histogram. So now you can see that your data quite ni. Jadi dia macam ni, positively skewed. Skewed ni towards positive. Okay, same goes to stem and leaf ni. Okay, the stem and leaf ni is very easy. You just draw the graph according to the values ni. So it's quite similar. This one pun indicate that the case is positively skewed. Kalau skewed dia ni towards ke sini, so dia akan jadi positively skewed. Kalau dia, okay, for example, skewed dia tu something like this. This one is negatively skewed. Okay, similar thing. Okay, next one. By using normal QQ plot. Okay, QQ plot. Okay, how to report the normal QQ plot ni? If you just look at the dots within the straight line in the graph ni. If the dot falls really close or on the straight line, so we can say that our data met the assumption of normality. Sebab to read the normal QQ plot ni is very subjective actually. Okay, but make sure that the dot here, the data here falls within the straight line. As long as it is close to the straight line, then we can assume or make the assumption or make the conclusion that our data met the assumption of normality based on new QQ plot. The trended QQ plot ni susah sikit, so tak apa ni. This one je pun cukup. Okay, next one. Box plot. Okay. This is another strategy to report your normality, in which you report the box plot. Okay, to read the box plot, okay, if the data, if the line here located at the middle, truly at the middle of the box, so then we can say that our data are normal. Okay, and then kalau let's say data ni, our data slightly downward, so this one is positively skewed. If let's say this line a little bit upward kat sini, then it is positively skewed.
Negatif tak?
Negatif terbalik terbalik. Negatively skewed. Okay. So ni pun salah satu cara yang kita boleh report data normality. So bukan saja statistik through Kolmogorov-Smirnov or Shapiro-Wilk ataupun skewness or kurtosis. So these are the alternative that you may use. Okay. So these outliers. Outliers ni nanti saya tekankan balik dalam bab regression. Nanti lihat ni, tunggu Okay, so to run the statistical analysis, there are few assumptions that mostly been used. Okay, so but it is depending on the type of statistic. Okay, if let's say you are interested to use the parametric statistic, okay, parametric statistic ni including the Pearson product moment correlation, multiple linear regression, simple linear regression, t-test, Anova. Okay, so you need to make sure that your DV or your IV, if applicable, met the assumption of normality. Okay, to prove that either your data met the assumption of normality or not, you need to indicate the related statistic lah, either Kolmogorov-Smirnov, Shapiro-Wilk, okay, skewness, kurtosis, box plot, QQ plot, okay, depending on you, depending on researcher. Okay, but to report this one, it is not necessarily to report all. Make sure you just report the statistic that support your interest. Do not report all. Even though you yeah, Mahfuz, yeah.
Confirm, just DV doktor. Maknanya IV tak perlu ke?
Okay, for example, if you use the t-test, because your IV is categorical, so it is not applicable to run the normality for your IV. So you just report the normality, data normality for your DV. But if you run the simple linear regression, then you need to report both IV and DV. Depend Faham Okay. So again for assumption of normality ni, make sure you just report analysis that support your finding. If you want to use, if let's say you run both Kolmogorov-Smirnov and Shapiro-Wilk statistic, but they do not support your finding, when at that time you want to use parametric, then do not report them. Okay, report the one that support your interest. Kalau tak, nanti jadi conflict of interest. Okay. Next one, assumption of equality of variance. So assumption of equality of assumption of normality ni mostly applicable to all parametric statistic. But assumption of equality of variance ni only applicable to statistic that involve comparison. For example, t-test, Anova, one-way Anova, two-way Anova. Okay, any statistic that involve comparison. Meanwhile, the assumption of linearity ni involve statistic that require that is related to regression, meaning that if we want to check either the relationship between the two variables are in straight line relationship, linear relationship. And this one we will discuss more in regression section later on. Okay. So this one how we can read or interpret the assumption of normality based on QQ plot. Okay. PP plot. Okay, ini je dia punya explanation. If values fall on the diagonal of the plot, then the variable is normally distributed. If the data set consistently above or below the diagonal, then it shows that the kurtosis differs from a normal distribution. If the data points are S-shaped, then it is considered not to be normal lah. Dia bukan linear. Kalau S-shaped. Tapi ni sebenarnya dia close lah, still close to the straight line. Okay. Tak habis ayat kat situ tu. Okay, this one normally skewness, kurtosis, tadi nak baca ni saya dah explain tadi. Boleh skip laju. And then assumption of equality. By the way, do you have any question related to normality? Any question? Okay, saya just refresh balik je ni. Semua dah pandai ni. Okay, next one, assumption of equality of variance. So again, this statistic we use or we report before we are able to run the analysis that require comparison. Okay, so we report the assumption of equality of variance or homogeneity of variance through leaving statistic. Okay, leaving statistic. Okay, so leaving statistic ni similar to Kolmogorov-Smirnov and Shapiro-Wilk. When we want to interpret the value, we refer to the significant value. Okay, in terms of the requirement, if the significant value larger or equals to alpha, then data make the assumption of equality of variance. If the significant value lesser than alpha, 0.05 or 0.01, so data do not make the assumption of equality of variance. Okay. Next one. Okay, assumptions of linearity. So this one, okay, some analysis, for example, linear regression needs the relationship to be linear between the IV and DV. So linearity assumption can be tested with a scatter plot. This is the most easiest to use. Kalau you all nak access this function, then you can click IBM SPSS, click graph, legacy dialog, pick scatter or dot function, and then choose simple scatter and define y-axis for IV and DV. Y-axis for DV, x-axis for IV. Inshallah, I will touch in detail later on in our regression section. This one. Okay, so these are the summary of the assumption according to the statistical analysis. Okay, if you want to use one sample t-test, then you need to run the, you need to make sure that the sample is normal. Okay, same goes to PET sample t-test. Okay, sample must be the DV lah population normality, maksudnya the DV must be normal. Independent sample t-test, you need to test for the DV as well as homogeneity of variance. Homogeneity of variance ni meaning that the distribution between the two groups. Okay, and then one way Anova. Okay, the DV must be normal, and then the group must be homogeneous. Okay, two-way Anova, both. Okay, population, normality, and homogeneity of variance. Bivariate correlation, only normality, both IVs and DV. Okay, and then simple or multiple linear regression, you need to check for both population normality as well as homogeneity and linearity. Okay, one-way analysis of covariance, this one advanced, and then factor analysis, and then MANOVA. Okay.
Doktor,
Yes.
MLR tu kena
Homogeneity of variance ada sikit. Later on I will discuss sikit. Nanti sampai section ni nanti kita akan tengok detail. Okay, this is the non-parametric equivalent test of the parametric test. Okay, this one in the case where if let's say early from the very beginning of your objective of the study, you set to use the parametric, but later on after you run the normality test, then it does not meet the assumption of normality, or after you do the transformation pun you all tak meet the assumption of normality. By the way, before you directly decide to use the non-parametric test, there is one option to transform your data before the final decision to use parametric ni. Ada kaedah lain maksudnya if let's say at the first stage we found that our data not to be normal, then we can run the transformation function. Okay, and then we test again either our data are normal or not. If still not normal, then we have no choice, we proceed with parametric statistic. Later on, inshallah, I will share with you on data transformation as well. Okay, so this is the non-parametric equivalent test of the parametric test. For example, independent sample t-test. Kalau dalam non-parametric, you can use Mann-Whitney-U test. Okay, for PET sample t-test, dia ada McNamara, Sine and Wilcoxon test. For one way Anova, we have Kruskal-Wallis. Through two-way Anova, we have Friedman and Cochrane test. Pearson product moment correlation, we have chi-square test of independent. And then we can also apply the Spearman rank order, pi and Cramer's V. Ini contoh. Okay. Okay, tak apa. Okay, ini tak apa. Ini kena detail ni. Ini saya skip dulu. Nanti saya skip ni. Okay. So any questions so far? Tak ada kan? Laju lah. Mengajar budak pandai senang. Refresh je.
Doktor, nanti boleh share slide.
Boleh. Saya lupa tadi nak upload. Saya just I just prepare for the attendance but forgot to upload. Nanti saya share balik Okay, next one we proceed with p-test. Okay, analysis that involve comparison analysis. Okay. So this is our LO objective. Okay, at the end of the session, you are able to identify the types of parametric statistic for comparing mean. Okay, statistical assumption necessary for comparing mean, analyze and interpret t-test and one-way Anova, and then report result according to APA style. Okay, so t-test, how many type of t-test are available? 3. Mahfuz tak tangan je. 3. Okay, there are 3 type of t-test. So the first one sample t-test, PET sample or dependent sample t-test, and lastly independent sample t-test. Okay. So why t-test? Why we want to use t-test? Because to compare differences between sample mean and a test value. Okay, we make sure when you report the t-test value, you indicate that we are comparing the mean value. Okay, there are differences between mean values. Jangan report different. They are different. Jangan different saja. Mean. Different in what? Mean. Okay. We want to compare mean difference between PET observation, and then we want to compare differences between 2 independent group means. Okay, so there are 3 reasons why we want to use t-test. Okay, we want to compare. Basically, we want to compare between 2 things, mean in 2 groups. Okay, so again, there are 3 types of t-test. Okay, sama ni Okay, so one sample t-test. Okay, the purpose of using one sample t-test is we want to compare the mean against a test value. Okay, so the single sample t-test compare the mean of a single sample to a known population mean. For example, we compare the current year's temperature to a historical average to determine if global warming is occurring. So in one sample t-test, we have only one data set. Okay, we only have one data set, and therefore we want to compare the finding that we have in our one data set into the existing finding, in existing standard finding. So for example, standard result for SPM, for example, is B. Okay, but in 2022, then we have C. So therefore, we compare the current result with the standard. Okay, so meaning that the data collection only happen for one group only. One group. Tapi similar with the standard lah, which is the SPM candidates. Okay. So in terms of the requirements, so the DV, both the DV must be interval or ratio. Okay, and then the test value or the value that we want to compare also must be either interval or ratio only. Okay. So the assumption for the one sample t-test, the score of the DV must be normally distributed. Mesti normal. Okay, and then the scale of measurement should be interval or ratio, and then the data must be collected from the random sampling from a defined population. Maksudnya we know our population and then we randomly pick the sample. Okay, and then we test our normality. Okay, ni tak apa. Then confidence interval ni, tak apa, ni skip. Laju. Tak apa. Okay, so what we need to know, okay, for one sample t-test ni, first we need to know how to run the analysis, one sample t-test analysis in IBM SPSS, and then identify the required statistics to be reported. We set our alpha, okay, and then we decide, we make our decision by comparing the statistic with alpha, with we compare the significant value with alpha. Okay, and then we present our finding, and then we interpret the result. Okay, and then prepare our report. So this is what we learn in this session lah. Lain sikit daripada kelas perfahaman Okay, so first to run the one sample t-test in IBM SPSS, first you click analyze, compare mean, and choose one sample t-test. Analyze, compare means, and one sample t-test. Done? Okay, analyze, compare mean, one sample t-test. Okay, in one sample t-test box, you pick PB variable. Ni contoh I choose PB. Okay, because in this data set, the PB is the dependent variable. So I choose PB. Okay, so for the test value, for example, it has been reported earlier that the philanthropic behavior mean for Malaysian citizen is 3, for example. So I just locate 3 under the test value column. This one must be historically or has been reported previously by previous researcher. Okay, clear
Doktor ulang balik yang test value tu.
Okay, test value ni, okay, again we refer to the earlier explanation regarding the one sample t-test. In one sample t-test, we only run or conduct the study by collecting the sample, by collecting the data from one sample, from one population. Okay, for example, I'm interested to know the philanthropic behavior or the tendency of Malaysian citizen to donate or to involve in volunteerism. Dua benda, donate and volunteerism in 2022. Okay, but previously it has been mentioned by JKM, Jabatan Kebajikan Masyarakat, for example, that in Malaysia, okay, the majority of Malaysia ni, the mean value for their philanthropic behavior is 3. Maksudnya it has been studied earlier, but I just run another study to reconfirm the finding. Okay, so the value, the mean value ni, the mean value that has been reported earlier ni, we locate under the test value. Faham Okay, just locate the standardized value ni under the test value. Okay, and then we locate our variable, our newly collected data under the test variable. Okay, next we click OK. Okay, click OK je, senang je. Then click OK. So this is the finding. Okay, so we have 2 tables, one sample statistic in which we'll report the mean, standard deviation, and standard error of the mean. Okay, and then the sample size. Okay, and then based on one sample test ni, Okay, at the above ni we can see the test value is 3. Okay, so our PB mean we report T DF, and then significant to tail, and then mean difference. Okay, so this is the two tables. And then okay, so what we need to report, actually we need to report the T value, okay, and then the significant value. Dua benda ni je yang we need to report. Okay, so we already identified the two values need to be reported. But in terms of making decision, what we need is the significant value only. Kita nak report, kita kena report dua-dua. But in terms when we want to make decision, what we need is the significant value, in which we want to compare the significant value against the alpha that we set earlier. Okay, so we set our alpha either at 0.05 or 0.01. Okay, so then we decide and present the finding. Okay, so we compare our significant value earlier that we obtained from the analysis, which is the significant value is 0.000. So then we compare against alpha. Okay, so the criteria for making decision is if the significant value or significant T lesser than or equal to alpha, therefore we reject hash knot. We reject hash knot meaning that there is a significant difference in both data. Okay, if the significant T, okay, since the significant T 0.00 lesser than alpha 0.05, okay, we can conclude that the sample mean is significantly different from the test value, which is 3 at 0.05 level of significant. So this is how we can interpret. Okay, we interpret the result. Okay, in terms of reporting the data into table, so this is how the table according to APA should looks like. Okay, table 1, result of one sample t-test in which test score equals to 3. Okay, we report the variable which is achievement, for example, this one saya lupa tukar, philanthropic behavior. N equals to 60, mean 3.86, standard deviation 0.48, T value equals to 13.94, and then significant P 0.00. Okay, table dia mesti macam ni. Okay, the spacing is single spacing, but this is how the one sample t-test table reporting should looks like. Macam ni. Okay. Tak apa. Ni effect size.
Doktor, kalau test score tu tadi kita tak buat 3, contohlah kan, kosong. So, and mean semua bahagian-bahagian bawah ni memang akan totally lain lah.
Okay, the mean tu dia akan berubah. T tu dia akan berubah. Mean tu sama. Mean will be similar because it is the mean for philanthropic behavior. Okay, but the T tu and P will be different lah. If let's say previous study indicated that dia punya comparison value adalah kosong. Biasanya kena letak lah, biasanya dia kena adalah test value tu. Okay, barulah dia akan jadi one sample. Okay, so then in this one is how to report your findings in your reporting. For example, a one sample t-test was conducted to test whether philanthropic behavior is significantly different among Malaysian and Mexican. For example, sebab satu study dah dibuat di Mexico. Sekarang kita buat kat Malaysia. So data were collected among Malaysian volunteers. So the result in which indicated in table 1, the sample mean score, mean equals to 3.86, standard deviation equals to 0.48, was significantly higher than mean test score, which is T, the degree of freedom 59, equals to 13.94, significant value lesser than 0.000. So the effect size, ini extra lah to report the effect size ni. Okay, ini tak apa, nanti saya explain later apa effect size. Okay. Okay, ni done. Any question? Okay, senang kan? Next one, paired sample t-test or dependent sample t-test, meaning that we measured the variable, we measured the subject twice through paired observation. Okay, the most easiest analogy is when we conduct the training. So we run the pre and post data collection to know the effectiveness of the training. Okay. Okay, the purpose to run the paired sample t-test is to compare mean difference between two repeated or dependent sample. Dependent ni maksudnya kedua-dua sampel ni berkait. Okay. In terms of the requirement, the pre-test score must be interval or ratio. The post-test score also must be interval or ratio only. Okay. Okay, the assumption, the pre-test and post-test scores must be normally distributed, meaning that the before and after data ni, data before, data after, you must run the normality test before you are able to make the comparison. Okay, next, the observation are independent of one another. Okay, the dependent variable should not contain any outliers. So you need to delete if there is any special case in your data set. Okay. Okay, dan tak apa. Confidence interval. Maju. Okay, so by the way, effect size ni, it add more flavor in your reporting. Other than you just report that there is a significant differences between male and female, but by reporting effect size ni, we know how much is the difference. Meaning that we quantify how much is the difference. Rather than we just know that there is a significant difference, but by reporting the effect size ni, we exactly report quantify how much is the difference. Okay, so to report the effect size ni, there are few statistics. The first one, D statistic. Okay, D statistic evaluate the degree that the difference deviate from 0 in standard deviation units. So dia punya rule of thumb is 0.2 equal to small effect size, 0.5 medium effect size, and 0.8 large effect size. Kalau ni based on D statistic. This is the calculation. Okay, the second option we can use eta squared. Eta squared. Okay, but no worries, in this class we are not highlighting on the manual calculation. I just include the manual calculation, but later on it just based on interpretation of the ready-made output only. Okay, so eta squared ni is an alternative to D statistic in which it range from between 0 to 1. Okay, the range ni for eta squared ni between 0 to 1 only. Okay, eta squared 0.1, 0.25 and 0.4 indicates small, medium and large effect size. Dia lagi besar lah compared to, lagi kecil compared to D statistic. Okay, D statistic ni, D statistic 0.2, 0.5, 0.8. So this one 0.1, 0.25 and 0.4 represents small, medium and large effect size. Okay, so this is the equation. Okay, so similar to one sample t-test, what we need to know is first run the analysis in IBM SPSS, identify the required statistic to be reported according to dependent sample t-test or PET sample t-test, set our alpha, okay, decide and present, decide based on by comparing the significant value against alpha, and then present our finding according to APA style. Then lastly, interpret the result, interpret and prepare the reporting. Okay, this is the extra flavor, and then you can add the confidence interval and effect size. Okay, to run the dependent sample t-test in IBM SPSS, you can click analyze, compare mean, PET sample t-test. Analyze, compare means, PET sample t-test. Done. Analyze, compare mean, PET sample t-test. Done. Okay, next one. Saya tak ada kod data tu kot. Saya tak bagi Set. I will reshare the data. Saya pakai data mana ni? Sebab data tu dalam data, the earlier data tu we do not have the pre and post. Hold on . Data mana saya pakai ni? Hold on . Hold on . Need to check. Mana data dia ni? Okay, tak apa, saya share data ni. Okay, I shared in our WhatsApp group. This is the data set on pet sample t-test, this one. Please open that file. Then, ready, ready? Ready? Mau diam tengah download. Or you want me to share in our chat box? Chat
Okay
box.
dah, Doktor.
Dah. Okay. So to run the normal to run the pet sample t-test for this data set, we just use quiz 1, quiz 2. Okay. So first, we click analyze, click compare means, and then pet sample t-test. Analyze, compare means, pet sample t-test. Okay. Analyze, compare means, pet sample t-test. Okay, so after the pet sample t-test, so this is how it looks like. Nampak tak? Saya punya pet sample t-test box ni, nampak? Okay, so now, saya reset dulu. Okay, so now we include our first reading and second reading. Okay, but for pair what? For variable here, when you want to insert your pairing ni, make sure you insert the post first. Post dulu because basically kalau kita nak, if you want to check the effectiveness, we will assume that the second reading will be higher than the first reading. Kan? Maksudnya kalau efektif tu, maksudnya dia punya score, our respondent score will be better for the second reading compared to the first reading. So we first include quiz 2 as variable 1, and then as the pair ni, the pairing ni, we include the quiz 2. Pairing. Then okay, then click OK. Okay, go to our output, then we can see that this is our finding. Sorry, kena share balik. This one. Okay, so this is our PET sample t-test output. First table will indicate the mean for both group, for both reading, quiz 2, quiz 1, the number of samples, standard deviation. Okay, and then it will indicate the correlation, tapi kita ignore this part. What we want to focus is PET sample t-test finding. Okay, so the mean of the difference, standard deviation for the different, okay, standard error of the mean for the different, okay, and then the t-value and then the significant value. So again, if you want to report, what we want to focus is the two value of t-value and significant value. Okay, t-value in terms of reporting, we need to report both t and significant t. Okay, but to make decision, we just compare the significant value against our alpha. Okay, so in this case, since the significant value lesser than 0.05, 0.05. Betul lah ni? 0.05, so the two, there is a significant difference between the two group ataupun the quiz tu has increased student understanding. As the option for the significant value ni, we also can use the 95 confidence interval to check for the different. Okay, in which we check on the lower bound and upper bound. Lower bound and upper bound. If 0 located outside the range, meaning that the result is significant. If 0 located within the range, there is no significant difference. Okay, kalau kita nak tengok ni option option to read the 95 confidence interval. Okay, kadang-kadang if you don't want to make your decision based on significant value, then you can, as an alternative, then you can refer to the lower bound and upper bound confidence interval ni. Okay, so to make decision based on lower bound and upper bound, you look at the location of 0 within the range. Okay, within the range. If 0 located within the range, okay, for example, in this case, if I illustrate in terms of graph, okay, so this is 0.159. So this one 0.869. So 0 located within or outside? Outside. Okay. So 0 kat sini. So since 0 located outside, so it is indicated that there is a significant difference between quiz 1 and quiz 2. So meaning that the student understanding increase after quiz 2. Dia punya understanding increase. Maksudnya kelas tu effective. Okay, the class session tu is effective, considered to be effective. Okay, but if let's say the value here, for example, negative 0.159 to 8.89 or 869. Okay, so I redraw the graph. Okay, so for example, here is negative 0.159, 0. Then here is 0.869. So 0 located within or outside?
Within.
Within. So we can indicate that, we can conclude that there is no significant difference. Sebenarnya biasanya sini ni dia akan tally dengan sini. Okay, biasanya dia tally sama.
Tutup balik pintu.
Okay. Next one, after we ni dah. Mana dah tadi? Okay. Dan okay, so this is the reporting, just similar to what we have just now. Okay, then set our alpha. Okay, and then before we decide, decide and presenting results. So we already made our decision earlier. Okay, so then we can include our, we can add more flavor or more description into our finding by reporting the effect size. For example, if you want to report the D statistic, okay, you just can you can just include you just can plug in the value into the equation D, okay, minus mu, okay, divide by standard deviation. Ni je. Dapatlah ni. Contoh ni. Eta square. Sebenarnya boleh request ni. Sebenarnya ni. Okay, so this is how to report the PET sample t-test. This is the table, the APA table. Okay, variable, mean, standard deviation, T, and significant value. Okay, you need to report the pre-test and post-test. Okay, and then this is how to interpret and report the results. So for example, a PET sample t-test was conducted to test whether training program can improve participant knowledge on ICT. So data were collected both before and after the training program among the training participants. So the result indicated in table 2 showed that the mean post-test score M equals to 15.1, standard deviation 3 was significantly higher than the mean of pre-test score. Mean equals to 12.3, standard deviation 1.89, T equals to 4.882, significant value lesser than 0.01. So the effect size, so this is how you can report your effect size. So the effect size, eta squared was 0.726, indicating a substantially large effect. Kita instead of we just know that there is a significant difference between the post-test and pre-test, so we report how much, we quantify how much is the difference, which is 0.726, indicate a substantially large effect size. So the results support the conclusion that the training program was effective to improve students' knowledge and ICT. Ni contoh. Okay, next one. Any question for PET sample t-test? No. Okay, next one, independent sample t-test. Okay, so the purpose of using independent sample t-test is to compare mean difference in DV, okay, between two independent groups. Kalau dalam PET sample tu, the groups or the sample that we use both in pre and post are similar individuals, similar group. But in independent sample t-test, the groups are different. Okay, the sample still similar, falls within the similar sample, but the groups are independent. Okay. So the requirement for DV, the DV must be interval or ratio, but the grouping, the IV ni must be nominal or ordinal, in which the number of group must be exactly 2. Cannot be less or cannot be more than 2, only 2. Okay, so the assumption, the score of the DV must be normally distributed for each group of the IV. Okay, itu saja requirement dia. And then lagi satu, sebenarnya the data must be randomly selected. Itulah. Okay. Okay, so ini the formula to select the finding in IBM SPSS letter. If the significant F, okay, significant F larger than alpha, we read the equal variance finding. Okay, if the significant F larger than alpha, we read the equal valence finding. If the significant F lesser than or equals to alpha, we use the unequal variance formula. We read the unequal variance finding. So because when we run the independent sample t-test, they will provide us with two findings. Either it is for equally varied, homogeneous, equal variance, or unhomogeneous. Okay, so unequal variance. So this is the indicator. Okay, confidence interval. Ni confidence interval dah, tak apa. Okay, so similar as what we learned in PET sample t-test, we can add more flavor in our description by adding the report on effect size. So effect size ni, there are a few options. The first one, the statistic. Okay, dia punya rule of thumb sama, 0.2, 0.5 and 0.8 indicate small, medium and large. Formula ni you can just ignore. Okay, the second option is eta square. The range falls between 0 to 1. Okay, so eta squared the rule of thumb is 0.1, 0.25 and 0.4 for small, medium and large effect size. Formula ni boleh ignore. Okay. So sama, what we need to know, first run the analysis in IBM SPSS, identify the required statistics, decide on alpha value, make decision and present, and then lastly interpret and report your finding according to according to APA style. And then you can also report as the option to significant value, you can report the confidence interval, and then you can add more flavor into your description by reporting the effect size, by quantifying how much is the difference. Okay. So to run the analysis, the independent sample t-test analysis in IBM SPSS, you can click Analyze, Compare Mean and Independent Sample t-test. Analyze, Compare Mean, Independent Sample t-test. This one, please use the original data ERS5951. Okay. Analyze, Compare Mean, Independent Sample t-test. Okay. Next one, in the independent sample t-test box, you choose PB mean and locate under test variable. Choose PB mean and locate under the test variable column. Okay. And then now for grouping variable, you choose gender. Choose gender. Choose gender, locate under the grouping variable. Okay. So then this equation appear. So next you click define group. Click define group. Okay. Then you just locate 1 for group 1, 2 for group 2. So you know lah. Okay. 1 ni either male or female. Check your own coding. Check again your own coding. 1 for male, 2 for female. Okay. And then click continue. Okay, next one, click option, tick for option here. Okay, under the interval, confidence interval percentage, you include 95%. Okay, for confidence interval percentage, just write 95% and then click continue. Okay, then go to your output to see the result. Okay, do we have similar finding? Similar tak? Sama tak?
Sama, Doktor.
Okay, so for first table ni will simplify the number of sample according to group. So we have male 30, female 30. Okay, the mean for each group, okay, 3.5333 for male, 4.1792 for female, and then standard deviation. Okay, next one. We go to the independent sample test table. Okay, so now, earlier I said that before we are able to choose which one to be reported, we need to refer to the significant F value. Significant F. So this is the significant F. So if the significant F larger than alpha, so we report the equal variance, right? Betul. If the significant F, lesser than or equals to alpha, so then we report the unequal variance. Betul. Okay. So now because we have two options, first, equal variance assume. Equal variance not assume. Equal variance assume ni means that equal variance lah. Homogeneity, the variance is homogeneous. Equal variance not assume meaning that our data not homogeneous. Okay, so now because of significant value lesser or larger than alpha? Larger or lesser? Significant value F, larger or lesser than alpha?
Less.
Less. So then we need to report
Unequal variance.
Unequal variance not assumed. Tak gerak pula. Okay, so this is the value that we need to report. So then we read the unequal variance not assumed values. So T equals to negative 7.153, degree of freedom for 4.926, significant to tail 0.00. So the mean difference, lower bound, upper bound. Okay, so based on the result of significant value, significant T value, there is a significant difference or not significant difference?
Significant difference.
There is a significant difference because the significant T is lesser than alpha 0.05. So then we can double check our finding by referring to the 95% confidence interval. If 0 located within the range of lower bound, upper bound, then the result is not significant. If the 0 located outside the range of lower bound, upper bound, so therefore the result is significant. So in this case, 0 located outside the range of negative 0.827 to negative 0.464. So the result is significant. Okay, next one. So we set our alpha and then decide and presenting the finding. Ni done. Laju. Okay. So again, we can add, we can quantify how much is the difference by report the D statistic. Ini we just plug in into the equation sahaja. Okay. Okay, so this is the table for independent sample t-test. So table 3, result of independent sample t-test on philanthropic behavior by gender. Okay, so gender, male and 30. Female 30, mean, we report the mean, standard deviation, and then T. Okay, T, the T value, the unequal variance not assumed, equal variance not assumed value. Okay, so this is the APA reporting. Okay, so an independent sample t-test was employed to test the difference in philanthropic behavior scores between male and female students. So as depicted from table 3, there was significant mean difference. T equals to negative 7.153, significant P equals to 0.000. So mean philanthropic behavior score for female students equals to 4.179, standard deviation 0.2434, was slightly higher than mean for male student. Mean equals to 3.533, standard deviation 0.237. So the effect size, eta squared, was 7.486. which is indicating a large effect. So the results support the conclusion that philanthropic scores between the two students group were significantly different. Okay, then any questions so far? Am I too fast? Laju dah slow dah rasanya. Okay. Boleh proceed lagi tak? Ni dah week ni dah lecture week 7. Sekejap ni, ke saya tertinggal ni? Okay, shall we proceed to the next one or we want to stop here? One Way Anova.
Boleh kot, Doktor.
Boleh lagi Okay, so we proceed with One Way Anova. Sekejap. Ada assignment 2 and 3 ke Doktor? Ada. Saya belum upload lagi. There is assignment 2 and 3 2 EDA t-test for One Way Anova. Dia sekarang ni if let's say we complete One Way Anova, then we already add assignment 4. Okay, Next one. Ni boleh laju tapi next week tu saya kena next after raya tu saya kena slow lah sebab that one will be on two-way Anova. Okay, so this is the next type of statistical analysis on comparison, which is one-way Anova. So the objective similar to the earlier objective. So this one is just the extension of independent sample t-test. So this one, a little bit history on one-way Anova, which is it is an initial technique of the analysis of variance that is developed by Fisher, okay, R.A. Fisher, and then it is also known as Fisher's Anova, as he's the one that introduced this type of statistical analysis. Okay, so one-way Anova ni is an extension for the independent sample t-test. Okay, it is an extension of the independent sample t-test, in which in independent sample t-test we have two independent sample. Meanwhile, in one-way Anova we have more than two groups, more than two independent groups. Okay, so we one-way Anova ni also known as one factor Anova because we only have one group that we want to compare. One group that has more than two categories. Okay, kita ada satu faktor sahaja yang kita bandingkan. There is only one factor that has been compared in one-way Anova. If let's say we have more than one, so now for example we have two factor to be interacted or two factor to be compared, then the name is two factor Anova or two-way Anova. If we have three factor, then three-way Anova. Okay, tapi dalam kelas ni kita belajar up to two-way Anova only. Okay, the purpose for using the one-way Anova is to compare differences between more than two groups, in which it is an extension to independent sample t-test. More than two group. Number of category dia lebih daripada dua. So the requirement, the DB must be interval or ratio. Meanwhile, the IB must be nominal or ordinal, in which the number of categories must be more than two, meaning that 3 and above. Okay. So the assumption here, the dependent variable must be normally distributed for each categories. Okay, for each categories. And then the variance of the dependent sample are the same for all the population, which is it must fulfill the homogeneity or equality of variance assumption. Okay, we refer to Levin statistic. Okay, and then the cases represent sample, a random sample, which is it must be randomly picked from the population. Okay. So ni tak apa. Okay, so there are three expectations in one-way Anova. So you are able to run the IBM SPSS, you are able to read the post hoc comparison table, and then you can report the effect size. Okay. Okay, so post hoc, if you may recall, post hoc comparison is a table that indicates in detail regarding the pair that is significantly different. Why we do not have the post hoc comparison table in t-test, in independent sample t-test? Why? Kenapa tak ada post hoc comparison ni? Because in independent sample t-test, it only involve two group, so we can directly see the difference through the output table tu. But for post hoc comparison, it involve the pairing of more than two. So kadang-kadang the IJ compare IJ pairing tu So I J K. So for example I J K I K J K. The pairing ni. Okay, so that's why we need the pair. We need to identify which pair that is significantly different. So that's why we need the post hoc comparison in one-way Anova. Okay, so then in post hoc comparison we use two key HSD, honestly significant difference, to check on the pairing difference, pair differences. We check for two key HSD. Okay, so the effect size, Okay, for the effects, to report the effect size for one-way ANOVA, we use the eta squared. So eta squared ni referring to the percentage of variance in the dependent variable accounted for by the independent variable. So the way we read the eta squared ni similar to R squared as in linear regression. Okay, so this is the equation. The next one is we can use the omega squared. Okay, so omega square ni sama juga dengan eta square. It is the amount of variance in the dependent variable attributed to the independent variable. So this is the formula for the omega square. Okay, so what you need to know, first run the analysis in IBM SPSS, identify the required statistics, set the alpha, decide and present, and then interpret and report the finding. You can also use the confidence interval as the option or alternative for the significant value, and then you report or quantify the effect size by using the eta square or omega square. Okay. Okay, so now go to our data set to run the one-way ANOVA. Okay, you can click analyze, compare mean, and one-way ANOVA. Analyze, compare mean, and one-way ANOVA. Okay. Next one, in the one-way ANOVA box, you include or insert the PB mean variable. Please include the PB mean variable. Done. Okay, in the data set, one of the variable that has more than 2 groups is education. So we pick education. We choose education. Okay. Next one, we click post hoc comparison. Post hoc. Okay, click post hoc. Okay. For post hoc, you tick for 2 key. 2 key. 2 key ni dia represent the 2 key HSD lah. Okay, tick for 2 key. And then click continue. Okay, then you click option. Okay, for option, under the option box, you tick for descriptive, homogeneity of variance test, and means plot. Okay, descriptive, homogeneity of variance test, and means plot. Okay, next, click continue. Go to your output to see the finding. You have similar finding? Sama Supposedly sama. Okay, so N for the descriptive table will indicate the descriptive finding for each categories. So 16 for diploma, 15 for bachelor, 14 for master, 15 for PhD. And then the mean values, standard deviation, standard error, 95% confidence interval, minimum and maximum. The next one is test of homogeneity of variance. Okay, so based on living statistic, the significant value is 0.798. So it met the assumption of homogeneity of variance or not? Since the significant value of living statistic equals to 0.798, larger or equals to 0.05, larger or lesser?
Larger.
Larger. So met the assumption or not, or does not meet the assumption? Lupa dah. Okay, so if the significant value of Levin test larger than alpha 0.05, so we assume that it met the assumption of homogeneity of variance. If the significant value lesser than alpha, so it does not fulfill the homogeneity of variance. So in this case, since the significant Levin statistic 0.798 larger than alpha 0.05, so it met the assumption of homogeneity of variance. So it fulfills the assumption, the required assumption to run the one-way ANOVA. Okay. Okay. Next one, Anova Table. Okay, so what we interested between group, for between group finding or within group? We are interested in comparing the between group or within group. Which one? Mana satu nak baca ni?
Between.
Between. Between group Okay, so mean that so we are interested. Why between? Because we want to know the differences between different categories. Okay, so then we refer to know either our model. To know either the data set there is a significant difference or not in data set. Then we first check on F and significant F. F and significant F. Okay, so again, to report your finding, you need to report both F and significant F. Okay, but in terms of making decision, we refer to significant value. So in this case, since significant value 0.999 larger or lesser than alpha 0.05? Larger. So the result is significant different or not?
Significant.
Larger ni. Larger.
Not significant.
Not significant.
No significant different. Okay, so since significant value, significant F value 0.999 larger than alpha 0.05, so there is no significant difference. Okay, so if let's say it indicated here there is no significant difference, so there is no point to proceed further to post hoc comparison table. Kalau kat sini tak significant, tak ada makna dah nak proceed kat sini. But if let's say there is significant difference in here, therefore you need to proceed further by reporting which pair that is significantly different, which you can obtain the information from post hoc comparison table. Faham You can check on this significant value to check on which pair that is significant different. Okay, kalau kita tengok kat sini, diploma, bachelor tak significant, not significant. Diploma, master does not significantly different. Diploma, PhD pun tak not significantly different. Diploma, bachelor dah. Diploma, master, bachelor. Now, bachelor, master. Okay, there is no significant different. Bachelor, PhD pun not significant different. Next, master, PhD, no significant different. Okay, again if there is no significant difference here, so there is no point to proceed further to report any findings on multiple comparison table. Tak ada dah kalau kat sini tak significant. But if there is significant difference in here, you need to proceed further by report the pair that is significantly different. Okay, so this is the purpose of post hoc comparison. Faham Okay. This is the finding if let's say ada yang significantly different. Okay, so then we check our table here, F and significant F. Okay, so in this case, significant F 0.00 lesser than alpha, which is there is a significant mean difference. So we can assume at least one pair will be significantly different. Okay, to know which pair, then we check on our multiple post hoc comparison. Okay, then in this table, we have three options. Either we want to directly pick the value that has flower on the top, or we can use significant value, or it can be based on confidence interval, 95 confidence interval. Mana-mana satu yang memudahkan. Okay, so first we can see from mid-size car and crossover SUV, there is a significant difference. Sebab apa? Sebab ada bunga ni, flower ni. Okay, and then based on significant value also, it is indicated that the significant value is lesser than alpha 0.05. Significant. Okay, and then in terms of 95 confidence interval, we can see that 0 located outside the range of lower bound, upper bound, between 6.52 to 22.02. Okay, yeah, sama. Dia akan align tiga-tiga ni. Okay, next one, full size car and crossover SUV. Okay, So mean difference is 10.182. Okay. In which we have a flower here on the top ni. Okay, so the significant value is 0.008, which is lesser than alpha 0.05. Okay, indicating that there is a significant mean difference between full size car and crossover SUV. Then when we refer to the 95% confidence interval, the range between lower bound and upper bound, we can see 0 located outside the range of 2.43 to 17.93. Okay. Yang ni samalah, tak ada dah. Yang ni we just report the similar reporting. So only two groups that are significantly different. Clear? Okay. Okay. Then we set our alpha, which is 0.05, either 0.05 or 0.01. Okay, this is how to report the finding. So since significant F 0.999 larger than alpha 0.05, there is no significant mean difference in philanthropic behavior among the three groups. Okay, so this is the table to report the one-way Anova finding and mean. Okay, significant standard deviation, F value, and significant F. Okay, then we can also report the effect size. Either we use the eta squared or omega squared. Okay, this is how to report the result. Okay, one-way Anova was conducted to test whether philanthropic behavior is significantly different. Okay, saya lupa letak ni. Across different level of education. So the result as indicated in earlier table. Okay, so we can see that no significant difference in philanthropic behavior between different level of education. With F equals to 0.01, significant value equals to 0.999. So the effect size also considered to be very small. Itu sahaja. Okay, ini yang untuk the second one tu. Okay, the second finding. So a one-way Anova was conducted to test whether expected injury is significantly different across different car size. Okay, the result indicated that there is a significant difference in expected injury between three different car size with F equals to 10.929, significant value equals to 0.000. According to post hoc comparison result, so mid size mean equals to 23.91 and full size mean equals to 19.82, both cause significantly higher degree of injury than did crossover SUV. So maksudnya dia cadangkan suruh beli SUV lah. Okay, instead of kereta yang besar-besar ni. Okay, boleh beli SUV ni cadangan yang bagus. Okay, next one. Okay, note the associated significant values of 0.000 and 0.008. So the effect size eta squared was 0.42, considered to be huge. Besar dia punya effect size ni. Maksudnya ada the difference are significant. So kalau those in automotive industry, they will be interested lah in this finding. Okay, that's all. Any question? Any questions so far? Tak ada Okay, so I thought we shall stop today. There will be no class next week So since next week Hari Raya, tak ada kelas lah Lepas tu saya akan kejar balik dua topik lah. Sebab nak kejar sebab some of you want to prepare your findings for your dissertation kan. So saya nak kejar yang simple linear regression and multiple linear regression.
Doktor,
Yeah?
sorry, ada one question.
Yeah?
Rusnida here.
Yes, Rusnida.
Ada satu soalan regarding last 2 weeks class about my
Okay.
dissertation. Just want to know your opinion, your point of view lah. My dissertation topic is about the relationship between work-life balance, stress, and job performance among junior doctors or housemen in the Ministry of Health.
Okay.
So I have 2 instruments. One of the instruments is to measure the stress level of these junior doctors to measure the stress level. So in these instruments, all items, 28 items is negative statements, negative items. All
Example?
the items. Example, fear of making mistakes that lead to serious consequences, work overload. My work is mentally straining, feeling of being underpaid.
Okay.
So my life is too centered on my work. So all these 28
That one
items,
under stress, right?
yes, under stress levels, just like Devian that you mentioned last 2 weeks. So in this case, I don't need to recode all these items, right, doctor? Because this is, yeah.
No need for you to record because by
Alright.
nature, stress is a negative behavior and therefore the items within it should be negative lah. Should be in negative
Ah,
form.
alright.
Yeah.
Yeah, don't need to record. Thank you,
Okay.
doctor.
Dan lagi soalan? Ya.
Itu sama macam konflik ke doktor?
Sama macam konflik.
Pun tak payah.
Pun tak payah. So make sure you know the direction of the variable, only then you can decide on the direction of the item. Okay? Tengok kalau job performance it's positive, for sure we want a high performing organization. Kalau deviance we want low deviance behavior. Stress pun we want low stress. Job satisfaction we want high level of job satisfaction. Kan, so item tu kena tallykan dengan your variable. Okay? Any more question? Adalah, jom pergi bazar. Okay, so if there is no more questions, so we stop here for today. Sebab kita dah habis dah 3 topik. Okay, so then before that, because since there will be no class next week, so I wish everybody who celebrate it selamat Hari Raya, maaf zahir dan batin. Okay, insyaAllah kita jumpa 2 minggu kemudian. Seminggu? Selepas 1 minggu. After 1 week. After 1 week. Okay, so Assalamualaikum semua. Take care ya.
Bersama.
Ya, doktor.
Selamat Raya, doktor.
Selamat Raya semua.